You know, we've managed to go hundreds of thousands of miles into space. But when it comes to the Earth, we've barely scratched the surface. Our planet's core is a magnificent mystery filled with secrets. Well, it's time to figure them out. The Earth's inner core is an extra-hot solid ball with an approximate radius of 760 miles. To put that into perspective, it's just 30% smaller than the Moon. But if we've never been there, how did we find this out? Well, we've learned about the core by observing the effects of gravity on objects on the surface of our planet. From there, it's estimated that the Earth's mass is 5.6 sextillion tons. Get out your bathroom scale. Nah, don't. The density of everything that lies on the surface is much lower than the core's average density. Scientists figured out that most of the Earth's mass is located towards the center of our planet. It's estimated that more than 80% of the core consists of one of the 10 most common elements in our galaxy – iron. But the iron on the Earth's surface is kind of limited. I know what you're wondering. How did the iron make it all the way down to the core? Well, there is a simple explanation. The heavy element somehow pushed itself, literally, towards the center of the Earth. And a ton, pardon the pun, of research was done to figure out how. Most of the Earth's surface is made of rocks called silicates, and the molten iron had some difficulty passing through them. To help you understand, think of how water struggles to get through a greasy surface. But in 2013, Wendy Mao and her team from Stanford discovered a possible solution for how this happened. They began an experiment to see how iron and silicate react when they're exposed to extreme pressure, like that in the core. They used a diamond anvil cell to pinch the two substances under those conditions, and they achieved it. The pressure was 330 gigapascals, which is around 3.3 million times the atmospheric pressure of our planet. The molten iron slowly squeezed through the silicate rocks, and they had their answer. It took millions of years for the iron to reach the center, so it happened at a snail's pace. Since snails weren't around back then, the iron had to guess how fast to go. Well, now that we have that figured out, how do we know what size the core is? That's when seismology comes into play. During an earthquake, shock waves are spread through the planet. Seismologists study these vibrations and try to read the reflections on the other side. It's like Thor is hitting one side of the planet with his hammer, and the seismologists are listening from the opposite end. But these vibrations also take different routes. They go through various parts of the planet, and that affects the sound they make at the end. Let's take a small detour for a minute. Seismology is quite an old scientific field. In the old days, when vibrations occurred, scientists noticed that something was wrong with them. These vibrations were S waves, and when they were supposed to show up on the other side, they just vanished. At first, they thought that something was wrong with their equipment, and it just wasn't picking up the vibrations. But as science progressed, it turned out that these picky S waves could only go through solid material and not liquid. So, something molten was present in the center of the Earth that was preventing the vibrations from going through. So they started digging into their data. They mapped out the paths of the seismic waves and found that around 1,860 miles from the Earth's surface, the rocks transformed into a liquid. But there's also an interesting fact in the game. Inga Lehmann was a Danish seismologist, and in the 1930s, she discovered a new wave pattern. First we had the S waves that didn't pass through liquid, but then there were also P waves that could travel through the core and appear on the opposite side of the planet. That was when Inga came up with a theory that the core has two layers. The solid inner core, which is around 3,700 miles below the surface, and the molten outer core, which is around 1,860 miles below our feet. When advanced seismographs were invented, her theory was confirmed, but that took 40 years. So now that we have the structure figured out, let's talk about how hot the core is and why. We've already established that we can't put a thermometer down there to study the temperatures. So scientists tried to figure that out by creating the same crushing pressures in their labs. Again, in 2013, a team of French researchers came up with the most accurate number that we've had in years. They put pure iron through high pressure, almost higher than that of the core, to come up with their findings. The temperature of the inner core is about 9,800 degrees, while the melting point of pure iron is about 2,800 degrees at the core. Its melting point is around 11,000 degrees. The fluctuation in those temperatures comes from factoring in the extreme pressure the iron is exposed to at the core. Also, other elements inside the core could be bringing the temperature down by approximately 400 degrees. But the reason it remains solid is because of the slow cooling of the outer core and its compression. The inner core spins faster than the Earth. That's caused by the thermal activity inside our planet, which creates the magnetosphere. Oddly, it takes a ton of time, pardon the pun, for heat to leave the Earth, but I'll get to that in a bit. There are three main reasons why the Earth is still boiling. The first one is that the core has remained hot from the time our planet was formed, roughly 4.5 billion years ago. Remember that number, because towards the end I'll explain how that happened. That heat hasn't been lost yet. In fact, the Earth is only cooling down around 200 degrees every billion years. Secondly, it generates heat from the friction of the dense materials as they move. And the last reason it's so hot is from the decay of radioactive elements. So why is this important? It makes it easy for scientists to understand how it affects the speed of vibrations that go through the core. Remember the P waves I told you about earlier? Well, these guys travel slower than they should while passing through the core. This shows that there must be some other element in there that we haven't figured out yet. Nickel is one of them, but when scientists ran some tests with nickel, the P waves didn't slow down enough. So they started digging, metaphorically. In 2015, a new study from Durham University came out. It claimed that 90% of the Earth's sulfur is in the core. So maybe that could be the missing element. Around 4.5 billion years ago, the Earth collided with a large planetary body that eventually tore apart our planet and formed the Moon. That incident left traces behind that led the studies in a new direction. When the impact happened, the Earth's mantle melted, and some sulfur-rich liquid squeezed through the ruins and reformed it. Some of it was probably lost in space, but the rest sunk to the core. Scientists from Durham University confirmed that theory by measuring the isotope ratios of elements in the mantle. They compared them to meteorites, which were possibly part of the Earth's original form. The problem was that there were so many different elements in the mantle, it's quite difficult to draw firm conclusions. So, they came up with another idea. Copper is usually bound to sulfur, so they analyzed the copper from the Earth's mantle and crust. Now, this was a 3-stage study done in different labs, using state-of-the-art mass spectroscopes. You still with me here? Good for you. They found that there was a teeny-tiny difference in the copper ratios between the Earth's mantle samples and the meteorite samples. That confirmed the theory that the Earth originally collided with another body, and most of its mantle just splattered around space. We also know that the core consists of some sulfur. Hopefully soon, we'll be able to find out what the other trace elements are. So, to answer your final question, yes, the center of the Earth is hardcore. Yes, you were waiting for that one, weren't you? Hey, if you learned something new today, then give the video a like and share it with a friend. And here are some other cool videos I think you'll enjoy. Just click to the left or right, and remember, stay on the bright side of life.